the terminology I'm going to be using is data warehouse terminology. And if you read Ralph Kimball's books, you'll find much better definitions of the terms there. The concept of the star schema, right? In the Oracle demonstration schemas, the star schema is the schema called SH. So standard data warehouse, you have tables that we call fact tables and tables that we call dimension tables. You see the word dimension now on the slide already. The fact table. In the SH schema, the fact table is a table called sales. The fact tables are the tables with millions, billions, trillions of rows. And in this demonstration schema, each row in the fact table represents a sale. Now, the table itself has dimension columns and what we call measure columns. The measure columns are the values that you're probably going to add up. You're going to total, you're going to maximize, you're going to average, whatever. These are the distinct values that identify that particular sale. The other columns are what we call the dimension columns. These are foreign keys to a dimension table. The dimension tables describe who the particular fact is relevant to. For example, every sale was of a certain product to a certain person. Who is that person? Well, that's a foreign key to, in this case, the table customers, keyed on cust ID. So that will be the foreign key going to the customer ID. Similar with products, there's a products table, there's a times table, a channels table, a promotions table. So these link to the dimension tables that describe further detail of who that sale is relevant to. But that's the actual fact of the sale is there. So that's your basic data warehouse, a facts table and then dimensions. So what do we mean by a star schema? A star schema, the dimensions are kept very, very simple. Oracle likes them to be as simple as possible. You denormalize the dimensions. And in the Oracle ideal world, your data warehouse is just two levels of table. You have the facts table in the middle, dimension tables hanging off it, to just one level. That means you denormalize the dimensions. Cast your mind back to how you normalize data. Every customer in this table, this is totally denormalized. Associated with each customer, you've got postcode, city, city ID, state province ID, country ID. Cast your mind back to normalization rules. Every column must be dependent on the key, the whole key, and nothing but the key. This is denormalized. We've got all sorts of repeated information here. But that's what Oracle likes to do. It likes you to denormalize your dimensions into simple stars. By contrast, we have snowflakes. The snowflake schema Oracle provides is the HR, human resources schema. This is properly normalized. We begin with the employees table. That's the equivalent of the facts table. These are the details of each employee. But one thing about them, and this is normalized, every value here depends on the key, the whole key, and nothing but the key. That then is a foreign key, just one foreign key in this case. Well, manager is a foreign key as well, but that will do for now. One foreign key. And that's going to departments. If we look at the departments table, every department has a name. If we denormalized it, we'd be storing the department name here. Every department is in a location. That's another table as we go out. There's the key back, the join column. Every location is in a country. Every country is in a region. So this is the normalized structure, or what you would call a snowflake. If you normalize your dimensions, you end up with a snowflake, a much more complex structure, as the tables radiate out to multiple levels from the facts table in the middle. So those are your two basic structures, star schemas or snowflakes. Bitmap indexes can work wonders with both.